Hello, this is Malachi Bishop, and this is RC-750, Rehabilitation Counseling Research and Program Evaluation. We are in week 5, and this is section 2. We're talking about inferential statistics. Inferential research is research that allows us to make inferences, and inferences are judgments or statements. We infer things about a population. So inferential research is research that allows us to make inferences about a population. And as we've discussed, because we can rarely study every member of a population, what we do in research frequently is select a sample from the population, and then we do some study. And then, based on the results of our study, we make inferences about the population based on what we find in our sample. So that's the idea of inferential research. Inferential statistics allow us to explore how likely it is that what we find to be true in our sample would be also true in the larger population. So the goal in inferential statistics is to rule out the possibility that our results are due to chance. These inferences are based on probability, the chances of a thing occurring. So for example, we talk about a 10% chance of rain, or you think about the odds that a horse will win. We're talking about probability, the chances that a thing will happen. And probability is the basis of inferential statistics. So I have a hypothetical study here. I've developed a flu medicine, and I've randomly selected 2 groups, a treatment group who's going to get the medicine, and they have the flu. So I've selected a group for a treatment or experimental group, and then I also selected a group of people who have the flu to be in our control group. And in the control group, those people are just going to get a placebo, a sugar pill. So let's say I did this study and gave the people in the experimental group, the treatment group, the medicine, and then I checked in on them the next day to see how many got better and how many were still sick. And in the treatment group, 25 people got better and 5 people were still sick on the next day. But in the control group, 20 people got better and 10 people were still sick. So based on those results, is that enough to convince you that my flu medicine is effective? What about if the results looked like this? What if half of the control group got better and half stayed sick, and in the treatment group still 25 got better and 5 stayed sick? Would that be enough to convince you? Or what if the results look like that? I think we're getting to more convincing evidence now that the flu medicine seems to be working. If you looked at that data, you might be convinced that there's something going on here, and these groups are clearly different from each other. One group is getting better a lot faster, or at a higher rate than the other group. So this would probably be enough to convince me. But the question is, where does that line lie? What is a big enough difference to convince us that these differences are due to the experimental condition, whether you took the medicine or not, and not just due to chance? And that's the question we're thinking about when we're thinking about inferential statistics. At what point does the difference become large enough that we feel comfortable saying that this drug is effective, or that the treatment group is significantly different from the control group? And how do we know that the differences we find are real and statistically significant and due to the intervention or experimental conditions, and not based on chance or sampling error? And what we do in inferential statistics, or with inferential statistics, is test the possibility that the results or differences that we find are due to chance. And the goal is to rule out chance and to be able to state with confidence that the results are not due to chance but to the intervention or manipulation, or that there are real differences between the groups and that these differences are not due to sampling error or the effects of the sampling method. We do this by making a testable statement, which is a hypothesis, that the independent variable did not have any effect on the dependent variable, or to put it another way, that any differences that we found between the groups are the result of chance rather than the result of experimental manipulation. So we make a testable statement to the effect that there is no difference between the groups. This is called the null hypothesis. We talked about this, we mentioned this idea before. The null hypothesis is a statement of no difference. And then there's the alternative hypothesis. And this is a statement of difference. So we're saying there is a difference between the groups, and the difference is based on the, we're hoping to show that the difference between the groups is based on the experimental manipulation. And the researcher hopes and expects to find that difference. So we have a null hypothesis which says there's no difference, and an alternative hypothesis which is a statement of difference. And what we hope to do as researchers generally is reject the null. We hope to reject the null and find that there is a difference between the groups. So there are two decisions that a researcher can make with regard to the null hypothesis. You can either reject the null hypothesis, or you can fail to reject the null hypothesis. And this is always a little bit confusing. Rather than just saying accept or reject the null hypothesis, we get into a little bit of double negatives, and so it's a little tricky, but that's the language that is used. So we have a null hypothesis that says there is no difference between the groups, and you can reject the null hypothesis, which is in effect saying there is a difference between the groups, or you can fail to reject the null, which is basically saying the null is correct, there is no difference between the groups. So we can make two decisions as a researcher. We can either reject or fail to reject. And then there are two possibilities in reality. So in the between the groups themselves, there actually can be a difference between the groups, and then sometimes there really is no difference between the groups. So there are two possible realities, and there are two possible decisions that we can make. I've tried to represent here two groups that basically look the same, and that's the idea I'm trying to portray here, that there is no difference between our experimental and control group. So I'm going to look at the four possibilities. Two possibilities are that we make the correct decision. The first correct decision that we might make when we look at a null hypothesis, that there is no difference between the groups. Right? If we collect the data and analyze the data, and we fail to reject the null hypothesis, and the groups look like these two groups with no difference between them, then we have made the correct decision. So that's one potential outcome. There is no difference between the groups. Based on our analysis of the data, we do not reject the null hypothesis. And in fact, in reality, there is no difference, no meaningful difference between the groups. So we made the right choice there. The other way we can make a correct decision is to reject the null hypothesis. So essentially we're saying, based on our analysis of the data, we will conclude that there is a difference between the groups, and the reality is that the groups are in fact different. So in this case, we reject the null, and the reality is that the groups are different. Then again, we've made a correct decision. So two possibilities for making a correct decision there, but then there are also two possibilities for making the incorrect decision. The first is, you can see again we're back to our two similar groups. There's no meaningful difference between these groups. And our null hypothesis is that there is no difference between the groups. So the error is going to be in our decision here. We collect and analyze the data, and we reject the null hypothesis. Based on our analysis, we reject the null hypothesis. So in effect, we say that there is a difference between the groups, but in fact there is not. So we made an error in this case, and we call this kind of error a type 1 error. A type 1 error is when we reject the null hypothesis. We say that there is a difference between the groups when in fact there's not. We can also make a type 2 error. And a type 2 error is when we fail to reject the null hypothesis. So in effect, we conclude that there is no difference between the groups when in fact there is. So you can see the groups are different this time, and yet we fail to reject the null hypothesis. And so when you make that kind of error, you've made what we call a type 2 error. We're going to talk more about type 1 and type 2 error, but because I think sometimes it helps to look at these things from different perspectives. That's one way of thinking about it. Another way of thinking about it is through the use of a table like this. Okay, again, the null hypothesis, there is no difference between the groups. And here on the side of the table, we have our two potential realities. The first is that the null is false. There is a real difference between the groups. And then the second is that the null is true. There is no real difference between the groups. So two potential realities. And then on the top of the table here we have two decisions. Our two can reject the null and conclude that there is a difference between the groups, and we can fail to reject the null and conclude that there is no difference between the groups, right? And as we said, two ways we can make a correct decision. If we reject the null and the null is false, then we've made the correct decision. If we fail to reject the null, we conclude that there is no difference, and in fact, in reality, there is no difference, meaningful difference between the groups. Then again, we made the correct decision. Type 1 error is when we reject the null, conclude that there is a difference when in fact there is not. And the type 2 error is when we fail to reject the null, so we conclude that there is no difference when in fact there is a difference between the groups. So type 2 error. Alright, so on what basis are we making this decision to reject or accept the null? It seems like you could just look at the groups, right? In these examples I'm showing you, you could do that. But we are talking about making this decision on the basis of statistical analysis. So using our inferential statistics, we make a decision based on our analysis. A few other components that we need to talk about here in inferential statistics. The first is the alpha level, and I'm sure you've seen and heard this before. The alpha level is the probability, the chances of making a type 1 error. So type 1 error, remember, is when we reject the null when it is true. So the probability of making a type 1 error we call the alpha level. The alpha level is something that we as researchers set. We determine what will be an acceptable alpha level before we do the analysis. Generally, in the social sciences, we set the alpha level at 0.05. So before we do our statistical analysis, we decide what level of probability we are willing to accept that we will be making a type 1 error. 0.05 is what we usually select in the social sciences. And a 0.05 alpha level means that if we took 20 samples, we would get the same results 19 out of 20 times. So that's one way of thinking of it. So if we found a difference between the groups, we would find that difference 19 out of 20 times. Another way of thinking about the 0.05 alpha is to say that there's a less than a 5% chance that the magnitude or size of the differences that we have obtained would occur when there is no such difference in the population. Alright, so there's less than a 5% chance that a difference as big as we found between the groups would occur in our sample if there were no difference in the population, or that the difference would have occurred by chance. So we're setting a level of basically how much risk we are willing to take that we make a type 1 error. I said in social sciences, researchers reject the null hypothesis when there is less than a 5% chance that the magnitude of differences obtained would occur when there is no such difference in the population. When the alpha is higher than 0.05, the chance of committing a type 1 error is higher. And when the alpha is smaller or lower, then the chance of committing a type 1 error is lower. A lot of times in medicine, when we're talking about working with medications and things like that, then you will see an alpha level being set at 0.01, much smaller alpha in medical studies a lot of times. And the reason is, when we're talking about things like how much medication you should take, the level of risk that you're willing to accept is quite small, because we can be talking about life and death circumstances. So if the amount of risk that we are willing to take is very small, then we set the alpha much smaller. But in social sciences, rehabilitation, counseling, we're generally willing to accept a risk of 0.05. Type 2 error, coming back to that idea, the researcher may also fail to reject the null hypothesis when it is false, right? So we said type 2 error is saying there is no difference when there really is a difference between the groups. The probability of making a type 2 error is called beta. So alpha is the probability of making a type 1 error. Beta is the probability of making a type 2 error. And there are a few factors that can lead to an increased beta, increased risk of making a type 2 error. And some of these are, first of all, unreliable measurement tools, or tools that aren't sensitive enough to distinguish differences. So if your measurement tool is unreliable or not sufficiently sensitive to measure the independent variable, differences that result from the independent variable are not detected. So if our measurement tool is not sensitive enough to find the differences, then we may make a type 2 error. We might say that there is no difference when in fact there was. We just didn't find the difference because our tool wasn't sensitive enough to detect the difference. Another issue is that our sample can be too small. So maybe we didn't find a difference, but if our sample had been larger, then we would have been more likely to find a difference that really does exist between the two groups. So both of these reduce the sensitivity of the study, the ability of the researcher to find or identify the differences that do in fact exist. The next concept related to beta is power. And the power of a statistical test refers to the sensitivity of the study, or the ability of the study to detect real differences that exist between the populations or between the groups. To reduce the likelihood of making a type 2 error, researchers try to design experiments with high power. And power is the opposite of beta. It's the probability that a researcher will correctly reject the null hypothesis when it is false. So this is basically the probability of making the right decision. Particularly, it's the probability of correctly rejecting the null hypothesis, so saying that there is a difference when there is in fact a difference, when the null is false. So if there is a difference, the probability that you will find it is power. And you may see, as you're reading research articles, you may see the authors talk about doing a power analysis. They'll often say, we did an a priori power analysis, which basically tells you, before doing the statistical analysis, how much power you will have and how many participants are needed to correctly reject the null hypothesis when it is false. So we do a power analysis before we do our statistical analysis, before we even recruit participants. And a power analysis can tell us how many people we need to recruit, how many participants we will need in order to have the level of power that we want. And there are three components of a power analysis, three things that go into this calculation. One is the sample size, one is alpha, and then one is called effect size, which is how large of a difference you want to have, how large of a difference is due to the independent variable. So how large of a difference you're looking for. So to increase power, you can raise the alpha. So for example, from 0.01 to 0.05, raising the alpha will increase your power. You can increase increase the size of your sample. Having a larger sample size will increase your power. Remember, we said too small of a sample size can lead to insensitivity, make it difficult to find a difference that actually exists. But if you get a larger sample, you'd be more likely to find a real difference. And then you can reduce measurement error. And this was another issue we just talked about. Having little measurement error, so having a reliable and sensitive measure or tool will increase the odds of finding differences between the groups and give you more power. So those are things you can do to increase your power, decrease your chance of making a type 2 error. Power is represented as ranging from 0 to 1, and it is equal to 1 minus beta. So remember, beta is a probability and power is a probability. Power of 0.80 is considered acceptable in social science research. That's what we're looking for, 80 or higher. What this means, if you see power equal to 80, this means that there is an 80% chance that if there is a real difference between the groups, it will be detected. And another way of thinking about that, because power is 1 minus beta, is the probability of making a type 2 error would be 20%. So if power is 80%, beta is 20%. If you want a high power, you want low beta. So just to summarize these ideas, alpha level is the probability of making a type 1 error, rejecting the null when it is true, or saying that there is a difference when there is not. Beta is the probability of making a type 2 error, failing to reject the null hypothesis when it is false, or in other words, saying that there is no difference when there really is a difference. And then power is the probability a researcher will correctly reject the null hypothesis when it is false. If there is a difference, it is the probability that you will find. So alpha, beta, and power. Null hypothesis. These are concepts we talked about making decisions based on inferential statistics. And so the next step, the next section, we will be introducing some of the more prevalent inferential statistics that you'll be reading about in the rehabilitation counseling literature.